Welcome back to the final lesson of this unit on rational functions and equations. This is from section 8.6. The goal for this lesson, or target, is when you complete the lesson, you'll be able to solve rational equations. This is our target for today. Please have it down for class tomorrow. Solving rational equations is going to initially take us back to elementary school, or maybe not elementary school, but middle school, and looking at ratios and comparing ratios. That's what really these are, rational functions, ratios. That's some kind of case word. And when we had two ratios set equal to each other, we got to cross multiply. So simple rational equations, we can just cross multiply. 20 times x minus 2 equals 5 times 3x minus 5. So 20 times x minus 2 equals 5 times x minus 3. You can go lots of different ways with this one. Probably most of you would just distribute the 5 to the 3x minus 5 and get 15x minus 25. And you can distribute the 20 to x minus 2 and get 20x minus 40. So at this point, we need to get all the x's on one side and all the numbers on the other. Subtract 15x from both sides, we get 5x minus 40 equals negative 25. From here, we do plus 40. This down. We get 5x equals 15. Divided by 5. X equals 3. It says always check your answers. So how I would check it is I would plug it back into my original equation and see what I get. I get 20 over 3 times 3 minus 5. And on the other side, does it equal 5 over 3 minus 2? Simplify each side. 3 times 3 is 9, 20 over 9 minus 5, and we have 5 over 1. 9 minus 5 is 4, 20 divided by 4 is 5, 5 over 1 is 5, they equal each other, they check out. So this is one of the simpler types of rational equations we're going to deal with. Obviously, we'll probably increase the difficulty as we go through. So what happens when we get an equation like this, where we have more than one fraction on one side? Well, what we have to do is we use the LCD, least common divisor, or LCM, excuse me, LCD, the least common multiple, to find the least common denominator. So the LCD, least common multiple to find the least common denominator. LCDs and LCMs here. So basically, how do I do this? I look at the denominators and I list out all the terms that are in the denominator. X, 3, and the next repeats. So it looks like our least common denominator will be 3x, or least common multiple. So what I do is I take that LCD and I multiply it by every single term, fraction, in the whole problem. And if I multiply everything by 3x, then really I haven't done anything to change the validity of this equation. So here we go. If I look and see what's going to happen when I do this, I'm going to simplify each of these fractions individually. If I look here, the x's cancel. 3 times 8 is 24. If I look here, the 3's cancel, and I get plus 11x. On the right side, the x's cancel again, and I get 3 times negative 14, which is negative 42. By multiplying through by the least common denominator, I end up clearing out all the denominators, and I don't have fractions anymore. Now it's just a two-step, simple algebra 1 equation that we all should have been able to solve before you even enrolled in this class. So we end up getting x equals negative 6. Obviously, we check it, plug it back in. 8 over negative 6 plus 11 over 3. Does that equal negative 14 over negative 6? Simplify each side. if I add negative 8 6 to 11 thirds, I could do that in my calculator, or I could see that reduces to negative 4 thirds plus 11 thirds. And negative 14 over negative 6 is just going to be positive 7 over 3. Negative 4 thirds plus 11 thirds is 7 thirds. Both sides equal each other. It checks. We have a 11. So x equals negative 6 is our answer. Okay, so what if we have one like this? You're saying, well, 2 doesn't have a denominator. Mr. Kuhn, how can I get an LCD for that one? Well, if it doesn't have a denominator, by default, the denominator has to be 1. So our LCD, we go through, we list them out. We have I see an x plus 3. I see a 1, which I don't need to rewrite that. And I see an x minus 4. So if I go through and multiply each of these terms by our LCD, we should have something that should simplify and get rid of all the fractions for us. So x plus 3 times x minus 4, multiply that by 3x minus 5 over x minus x plus 3 equals 2 times x minus x plus 3 times x minus 4 all over 1. We write that again, I don't think. And we're going to add that to 8 times x plus 3 times x minus 4 all over x plus 3 times x minus 4. So now we're going to cancel out whatever we can and then simplify from there. Those cancel out. I end up getting x minus 4 times 3x minus 5. That means I have to FOIL it or use the box. We get 3x squared minus 5x minus 12x plus 20. When I simplify that, I get 3x squared minus 17x plus 20. Over here, that equals, on this side, we're going to have a little work to do here as well. X times x is x squared. X times negative 4 is negative 4x. 3 times x is 3x. 3 times negative 4 is negative 12. Still have that 2 to distribute. Oops, negative 4 and 3 is negative 1. Multiply that all by negative 2. I end up with 2x squared minus 2x minus 24. And then over here, you say, wow, this is pretty hard. Well, we got lucky. This one, everything cancels out and just leaves us with a positive 8. So, here's what we boiled it down to. Well, we can probably clean up this side a little bit more. Combine select terms, you get negative 16. We have a quadratics on either side. We could set them equal to each other in the graphing calculator and see where they cross each other. That's one way to go about it. This would be y1. 3x squared minus 17x plus 20 would be y1. The other side would be y2. Or what we learned was set everything equal to 0. So that means I would move everything over to the left. I'm choosing to move it over to the left because I like to keep my x squared term positive if I can. So I'm just going to undo everything on the right and move it over. I end up with an x squared minus 15x plus 36 equals 0. So now I can use bottoms up. Say, okay, what multiplies to make 36? What adds to make negative 15? Well, the combination that does that is negative 12 times a negative 3, negative 12 plus a negative 3. Checks off. I get x minus 12 times x minus 3. Bottoms up says divide by a. A is 1. That's not going to do a whole lot for me here. So I do x minus 12 equals 0 and x minus 3 equals 0. Solve each one. I get x equals 12 and x equals 3. Now, when we do it this way, you really got to go back and check your solutions. You got to go back to that original equation and make sure that both equations work, or both values work in the equation. 3 times 12 minus 5 over 12 plus 3. Does that equal 2 times, or 2 plus 8 over 12 plus 3 times 12 minus 4. So we're going to simplify this and see if both sides equal each other. We get 36 minus 5, which is 31, over 12 plus 3, which is 15. Over here we get 8 over 12 plus 3, which is 15, times 8 plus 2. So we get 2 plus 8 over 120. Does that equal 31 over 15? So now I would probably just go to my calculator. We could get like terms 2 plus 8 divided by 120. And then I'm going to hit math fraction. It's 31 over 15. So we can see that one works. That was 12. So we've checked 12 works. And 3. Do the same thing for 3. 3 times 3 minus 5 over 3 plus 3. Does that equal, point missing, 3 plus 3 over 3 minus 4. We get 9 minus 5 over 6, which is 4 over 6, or 2/3. We can simplify this side to 2/3. We have a winner. 3 plus 3 is 9 times a negative 1. That's 9 times negative 1 is negative 9. 2 plus negative 8 over negative 8/9. Just look back and realize that I said 3 plus 3 was 9. 3 plus 3 is 6. No wonder this wasn't working out. 8 over negative 6. How about that? That worked out a little bit better. 2 plus 8 over negative 6. 8 divided by negative 6 is 0.66. We hit math fraction. We get 2/3, which is what we got over here. Both answers work. So let's go up here. We can circle it. Both answers are actual answers, no extraneous solutions. Okay, last one real quick. If you get something like this, it might be easier to try and factor the pieces and make sure what you're multiplying by a little bit less than if we just straight up multiply by x squared minus 16 at the top and the bottom. So here are the original terms factored completely, which really was just the x squared minus 16. And we can see that x squared minus 4 and x minus 4 and x plus 4 are the LCD. Those are the only terms that repeat on the denominator. So I'm going to multiply all the numerators by x minus 4 and x plus 4. So we multiply that through. We're going to get some canceling. Presumably over here, everything cancels out except for the 6x squared. On this one, we get the x plus 4's to cancel out, so we can probably distribute that to having negative 3x squared. And that would be negative 3x times 4, which is negative 12x. And over on this side, 4x minus 4 is canceled. And I'm left with 4x plus 16. So we have some terms that we can combine here, it appears. We have 3x squared negative and 6x squared positive. That makes 3x squared minus 12x. Oops, that should have been a minus. Positive 12x here. This is a minus 4. This is a plus 4. So this is plus 12x equals 4x plus 16. Well, another situation where we're going too fast. We can make little mistakes. Subtract 4x from both sides, subtract 16 from both sides. We end up with 3x squared plus 8x minus 16 equals 0. So now we solve this one. Bottoms up looks like the way to go. I don't think you can factor any monomials out. So what multiplies to make 3 times negative 16, which is negative 48, and what adds to make 8, which is B. Well, you can take some time, but negative 4 times 12, that makes negative 48. Negative 4 plus 12 adds to make 8 with checks. So x minus 4 times x plus 12. You really have to do bottoms up this time because a is 3. So we divide by a. 4/3 can't be reduced, so that becomes 3x minus 4. This does reduce, that becomes x plus 4. So our zeros are now 3x minus 4 equals 0, and x plus 4 equals 0. See there. So we solve, we get 3x equals 4, or x is 4/3, and we get x is negative 4 here. So we should check these. We check them. We plug in negative 4. We get 6x squared. 6 times negative 4 squared over negative 4 squared minus 16 minus 3 times negative 4 over negative 4 plus 4 equals 4 over negative 4 minus 4. And we should see issues right here. This denominator is going to be 0, which is undefined, which tells us right off the bat, negative 4 is not going to work. That's an extraneous solution. If you went through and plugged in 4/3, you would find that it worked. I'm going to let you guys do that, save some time here. But 4/3 is our only solution, so we did have an extraneous solution for this one. Okay, so we had a simple target today, and we saw there's lots of different variations of rational equations. I believe we did come up with the ways to solve them. Make sure you're checking your answers every time, as sometimes there are extraneous solutions and you have to find those. If you say something's a solution, it's really not. You're going to lose points on your tests and on your assignments. I'll have those for tomorrow. We'll get going on assignment class. Have a great day.